Welcome to the 7th video of What Should I Watch While Eating series. Galaxies are the grand structures of our universe. These vast islands of stars, gas, and dust are scattered throughout the cosmos. They are the birthplaces of stars and planetary systems. Galaxies are dynamic entities, constantly evolving and interacting with their surroundings. Their story is a tale of immense forces, incredible distances, and timescales that dwarf human comprehension. Imagine looking up at the night sky and seeing not just stars, but entire galaxies, each point of light representing billions upon billions of suns. Each galaxy a swirling, luminous masterpiece. From our perspective on Earth, we can glimpse a small fraction of these cosmic islands. Their beauty and mystery have captivated astronomers for centuries. To understand the life cycle of galaxies, we must journey back to the very beginning. Approximately 13.8 billion years ago, the universe was born in a cataclysmic event known as the Big Bang. In the first fleeting moments after the Big Bang, the universe was an unimaginably hot and dense soup of energy and elementary particles. As the universe expanded and cooled, this primordial energy began to condense into matter. The first atoms to form were primarily hydrogen, the simplest and most abundant element in the universe, along with a smaller amount of helium. These atoms were not evenly distributed. They clumped together due to gravity, forming vast clouds of gas. These clouds, remnants of the Big Bang, would serve as the building blocks of the first stars and galaxies. Within these swirling clouds of hydrogen and helium, gravity began to exert its pull. Dense regions within the clouds contracted under their own weight. As these regions collapsed, they heated up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. This was the moment of stellar birth. The first stars, massive and short-lived, blazed with incredible intensity. They flooded their surroundings with intense ultraviolet radiation. The intense radiation from these early stars ionized the surrounding neutral hydrogen gas. This process, known as reionization, marked a pivotal transition in the early universe. It transformed the universe from a state of darkness to one filled with light. The death throes of these early stars, through supernova explosions, seeded the universe with heavier elements. These elements, forged in the hearts of stars, became the building blocks of planets, moons, and eventually life itself. A tapestry of galaxies. As more and more stars ignited within these primordial gas clouds, they began to clump together under their mutual gravitational attraction. These clumps of stars, along with leftover gas and dust, formed the seeds of what would become galaxies. These early galaxies, known as proto-galaxies, were smaller and more irregularly shaped than the majestic spiral and elliptical galaxies we observe today. Over billions of years, proto-galaxies grew and evolved through a combination of processes. They pulled in gas from their surroundings, accreting material and fueling the formation of new stars. They also interacted with each other, sometimes colliding and merging in spectacular events. These mergers could scramble the stars and gas within the galaxies, triggering bursts of star formation and shaping their overall structures. Galactic transformations. The galaxies we observe today are not static entities frozen in time. They are dynamic systems constantly evolving and interacting with their surroundings. One of the most striking features of many galaxies is their spiral arms. These arms are regions of enhanced density where star formation is particularly active. The Milky Way, our own galaxy, is a barred spiral galaxy. It is characterized by a central bar-shaped structure and two major spiral arms. Elliptical galaxies, in contrast to spirals, have a smoother, more rounded appearance and contain less gas and dust. They are thought to form through the mergers of smaller galaxies, with the violence of the collision stripping away much of the gas and dust, leaving behind a population of older, redder stars. Irregular galaxies, as their name suggests, lack a defined shape. They often result from gravitational interactions or mergers with other galaxies, distorting their structures. As galaxies continue to evolve, they consume the gas and dust that fuels star formation. Over time, the rate of star formation within galaxies slows down. The once vibrant stellar nurseries fade as the raw materials for new stars are depleted. The universe, once ablaze with the light of newborn stars, gradually transitions into an era of stellar twilight. Existing stars exhaust their nuclear fuel and reach the end of their lives. The fate of a star depends on its mass. Massive stars end their lives in spectacular supernova explosions, briefly outshining entire galaxies. Less massive stars, like our Sun, will eventually shed their outer layers, leaving behind a dense core known as a white dwarf. As the universe continues to expand and cool, the remaining galaxies will become increasingly isolated from one another. The grand cycle of galactic evolution, from the chaotic birth of the first stars to the slow fading of starlight, reflects the fundamental nature of the cosmos. It is a universe characterized by both creation and destruction, where vast timescales and immense forces shape the destiny of galaxies. As we continue to explore the cosmos, we gain a deeper appreciation for the intricate processes that have shaped the universe we observe today. Subscribe for more cosmic stories.